Hello and welcome to day 2 of circles. This is arcs. That's what we're going to be dealing with. And so again, there's going to be a whole bunch of definitions that you need to write down, and you need to make sure you know what they mean, because this is what the terms that we're going to be talking about in class. So please get these down. So basically we're starting out with a central angle, and a central angle is an angle whose vertex is on the center of the circle, and it has it's basically made up of two radii. So this right here, ADB, this angle down here, is a central angle because it goes to the center of the circle D. If that central angle is less than 180 degrees, we call it a minor arc. So the minor arc would be labeled AB with a little arc symbol above it to represent that it's an arc. A major arc is an arc that is over 180 degrees, and usually major arcs are labeled with 3 letters and minor arcs are labeled with 2, but sometimes minor arcs are labeled with 2, just for depending on how many angles and stuff are in there. But the major arc in this case, ACB, would be our major arc because it's greater than 180 degrees. Now what happens if it's 180 degrees? Well, if I was to extend this so that we had a diameter, then we'll call this point E down here, then the arc ACE, or even ABE are semicircles. So if the endpoints are on the diameter of the circle, then like A and E are on the diameter, then what you get, the corresponding arcs are semicircles. They're halfway across this shape. Some more definitions when we're talking about minor arcs. Well, minor arcs are defined by their central angle. So if this angle is 60 degrees, then the measure of arc GF is also 60 degrees. So that's what we're talking about. And so this arc length in degrees is 60 degrees. Down here, if we went with GEF, the major arc is basically taking 360 degrees from, taking away 60 degrees from the 360 degrees, and that would be my major arc, which we'd label as GEF, and so we'd get that that's 30 degrees. Now, things that we can learn from this, we know that a semicircle, EF, and probably, or EGF if you want to call it that, EGF would have a measure of 180 degrees. So E to G to F would be my semicircle. It's 180 degrees. Semicircles are always 180 degrees. And then in that case, that would mean if 60 degrees is taken up by GF, then arc EG would have to be 120 degrees to make up the difference. So you can kind of learn some things from this, and then we could find out, if we could find out where some other measurements and things like that if we wanted, if there were other angles in here. So that's kind of the way you're going to be working with these guys. The next one, we have an arc congruence definition, and basically we're saying two arcs in the same circle, or congruent circles, meaning you can be two different circles but they are the same radii, are congruent arcs if they have the same measure. So if the circles are congruent, or you're on the same circle and the arcs are both 60 degrees, those are considered congruent arcs. Now, we have some theorems that go along with this, and they're chords. And remember, chords are segments that are on the circle, that endpoints are on the circle, like AB and BC. So when we have their chords, it gives us a little bit more information. And so it says, in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So arc AB would be congruent to BC if and only if segment AB is congruent to segment BC. And so now you can see why, if we're using the little arc symbols, is kind of important, because one, even though they're the same letters, one of them is a straight line to represent a segment, a chord, and the other one is an arc to represent that you're going around a curve on a circle. So pause this if you need to copy it down. And then we have, if the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we would know that this diameter is perpendicular to the chord DF, so that means that DE, segment DE, is congruent to EF, and we also know that arc DG will be congruent to arc GF. And so we know that from this theorem. So please make sure you copy it down. if we have a chord, just two more theorems here, if we have a chord that is a perpendicular bisector to another chord, then the first chord is the diameter. And this kind of is the flip of the previous one. So we're saying, since we know that before we said that the diameter bisected a chord and met it at a 90 degree angle, we would end up with getting two equal chord pieces and two equal arcs. Well, it works the same. These guys would also be the same. So maybe the diameter piece gives you two congruent arcs and meets a chord at a 90 degree angle. That would also mean that you have a diameter. So JK is the diameter of the circle. And then finally, in the same circle or congruent circles, if two chords are congruent if and only if they're equidistant from the center. So we're saying that AB is congruent to CD. AB is congruent to CD if and only if EF, the little segment EF, the distance to the chord, is congruent to the distance EG, which is the distance to the chord. And so these are all the theorems that we're going to be talking about, theorems, definitions that we're going to be talking about in class, so please make sure you have these down. If you need to rewind or pause it as I was going through this, please do so. I'll see you guys in class.